Section 5.7 is going to continue to work with the product of two binomials. There's a couple special cases that we're going to work with. We're going to work with the square of a binomial and another special product. So stuff like this. Now one thing that people want to do all the time when we square this out is say, oh, well, that's a squared plus b squared. In fact, it's not. In order to calculate this, you're going to multiply a plus b times a plus b. Or likewise over here, a minus b times a minus b. And what you don't get is just a squared plus b squared. That's not true. You can't square these out by just squaring each of the n terms. Instead, if you square this out carefully, you're going to get a squared plus ab plus ba, but I'll write that as ab plus b squared. Now these middle two terms are the same, so we can combine them. They're like terms. You end up with a squared plus 2ab plus b squared. Likewise over here, if you FOIL this one out, you'll end up with a squared minus 2ab plus b squared. And again, you can't just square the n terms when you're squaring this thing out. Now my suggestion to you at this point is that when you square these types of things out, that you just repeat the binomial and multiply it by itself. So we'll start with problem number 10, y plus 7 squared. And we'll start by multiplying that by itself. That is, write y plus 7 times y plus 7. What's the word that helps us multiply this stuff out? FOIL. So first, outside, inside, last. Kesanaya, first terms, what would that give me? All right, y squared, good. It's not true. I pull problems. I never pull out the hardest ones. All right, all right. So y plus, or 6y plus 3 squared. Again, multiply the binomial by itself. A little more challenging on this one. Help me out with the first pair. 36. Good. So 36y squared. All right, keep going then.
Plus 18y plus 18y plus 9.
Good. Now, when you're multiplying these binomials out, when you're squaring them, that middle term, your first and your outside and inside are always going to end up being the same. You'll get it twice when you're squaring these things. Combining like terms, 36y squared plus 36y plus 9. Can I combine like terms any farther? That's it. It's as far as you can go with this. These are not like terms. Okay, let's have you try one. Problem number 16, 9b minus 2 squared. Give you a moment to work on that. Yes, it's a 9. Okay. Timer, what'd you get?
I got AB squared minus 2AB minus 2AB plus 4.
This is a 9.
Oh,
Sorry.
sorry. Well, it's going to be 9B squared.
So 9 times 9 would be 81 b squared. All right.
Should be 81B. No, 18B
18b.
minus 18B
Good.
and plus 4.
Perfect.
And it's going to be equals 9B squared. Sorry,
80.
18B squared, yeah. And minus 4AB.
Well, if you combine the like terms here, negative 18 and negative 18 gives you
36.
negative 36. Good. So, good. Thank you. Let's try something a little bit more challenging here. Problem number 20. So, d plus 0.2 squared. So, you got a decimal in this one. Yay, it's all right. We're still going to work at the same. Multiply this by itself. First two terms, George.
B squared plus D.0.
All right, 0.2d. Good. Yeah, typically you write the number part first. You're not wrong in writing it as d times 0.02, but typically we write the number part first. And then you get the same term again, right? 0.2. Now, it's up to you how you want to do this. I mean, you can, if you want, take out your calculator. 2 times 2 is 4. And there should be 1, 2 decimal digits. So 1, 2 should be 0.4. You can multiply 0.2 by itself on your calculator. That's fine. What's my final answer here? Jacqueline?
D squared plus 0.4b
Mm-hmm.
plus 0.04.
Perfect. Perfect. Thank you. And thanks, George. Okay. Let's try problem number 22. C squared plus d squared raised to the second power. Can I say that that's just c to the fourth plus d to the fourth? No. Doesn't work that way. If you write that on an exam, let me thank you in advance. You're making my job of grading very easy. But it's wrong. Sorry. So let's work this out by multiplying it by itself. C squared plus d squared times c squared plus d squared. This one's kind of a strange coincidence. When you multiply these things together, c squared times c squared, are you going to add the exponents or multiply? Add them. Although if you accidentally multiplied, you get the same thing, right? All right, but that's not always the case. We should know that we're going to add them, so it's going to be c to the fourth plus c squared d squared plus c squared d squared again. Typically, you write these things in alphabetical order. How about the last terms? When I multiply those together, what would that give me? D to the fourth. C squared plus, or c to the fourth plus 2c squared d squared plus d to the fourth. So again, combining the like terms here and here. All right, so that's about it for squaring out the binomial. Yeah, please. This one or up here?
The middle.
The middle.
2c squared.
Oh, it's enough to have it in front of one, the whole thing. So what's going on is that I have one of these terms here and one of them here. So one of them plus one of them gives me two of them. Yeah, no, appreciate the question. We're going to move on to multiplying this together. A minus b times a plus b. It's another special product in terms of working with the product of two binomials. Now, some interesting things happen when we multiply these together. Let's see that first in particular, and then we'll see it in general. Y plus 6 times y minus 6. These are called conjugates. When you have two binomials that are almost the same, the only difference is the sign of the terms between these things. So let's FOIL this out. So y squared minus 6y. Good, plus 6y.
minus 36.
Thank you. Is there any cancellation, simplification? What happens to these two terms? Yeah, they cancel out to 0. Now don't put plus y, don't put 0y, just leave it off altogether. This is just y squared minus 36. So those middle terms canceled. And that's always going to happen when you're multiplying out binomials like this. A squared plus ab minus b squared is just a squared minus b squared. So that kind of thing is always going to happen. But let's practice FOILing it out anyways. We'll continue with problem number 30. 5a plus 4 times 5a minus 4. How are we doing on this one? Megan, what will the first terms be?
25
Good? Outside? Minus 20a plus 20a, good? Excellent. So, as before, the middle terms are going to cancel themselves out. And we get 25a squared minus 16. A couple more here to finish out the section. Problem number 34. 0.3 minus 2c squared. 0.3 plus 2c squared. So another one that deals with decimals. It's all right. You can take out a calculator if you need to multiply those together. I'd rather you do that than just kind of charge ahead and get it wrong. So, Ted. First terms. Good. So 0.09. Good. All right. Plus 0.6 c squared. Excellent. And the last term, minus and a plus, will be a minus what to? Perfect. Yep, the two middle ones annihilate each other, and we're left with 0.09 minus 4c to the fourth. Excellent. One last one like this, problem number 36. 6 minus c squared, 6 plus c squared. Thanks again, Ted. Nick, your turn. First terms. Good. Mm-hmm. Excellent. Good. Well, you're multiplying them, right? So minus times a plus is a minus. C squared times c squared gives you c to what power? Excellent. Did you add the exponents there or multiply them? When you're multiplying things with the same base, you add the exponents. So it'd be 2 plus 2. Yeah. Okay, so those cancel each other out. We're left with 36 minus c to the fourth. Okay, thank you. Yes, question?
When we're doing this, will we always write the first number there in front, or put in the C?
You know, it's a great question here. A lot of times, if you're being really formal and careful, you write your terms, your polynomials in descending order of the exponents. So you could write it like this. That'd be fine. I'm not necessarily going to ask for this, but this is probably a more formal way to write it. So yeah, good question. All right, one last one from this section. And let's do problem number 48. There's a lot going on in problem number 48. A minus 1 squared minus a minus 8 times a plus 8. Now with this one, we're going to need to be a little bit more careful than usual. Let me do a couple things here. Let's put parentheses around this term, or kind of brackets around this term, and then likewise around this term. Because we're going to calculate these things out in the brackets slash parentheses first, and then we're going to do the subtraction. My worry for us here is that we're going to accidentally drop a sign someplace. So minus, and then I guess I can start foiling this out. A times a is a squared plus 8a minus 8a minus 64. Let's do likewise here. We'll FOIL this out. 25a squared minus 5a minus 5a again plus 1. And now we're going to see why I wanted to write those brackets there. It's very easy to make a mistake with the sign here. What has to happen when we subtract these two polynomials? What do you suggest we do? Good, distribute the negatives. So I'll get rid of the parentheses or brackets around here. Actually, you know what? I should combine like terms first, right? It's going to be a minus 10a. Minus 10a plus 1. Minus a squared. What happens to the minus 64 here? Good. Negative times a negative is positive, so it becomes a plus 64. Well, we have some like terms that we can combine, should combine. Let's do that. Question? All right, so the like terms would include the a squareds. Yes, you're right. 25a squared minus a squared. How many do I have? 24a squared. There's other like terms as well. Good. 1 and 64. Are there any like terms for the minus 10a? So minus 10a plus 65. That's as far as we have to go with this one. All right, a little bit challenging there at the end, but hopefully pretty doable. How are you looking on section 5.7? Pretty good there? This is a good heads up as far as what's coming up in section 5.8. That is, part of our work in dividing polynomials is that we're going to have to subtract. And notice what we did. We changed the signs, then just added, right? Distribute that negative sign, it changed the signs, then you just added. 25 plus negative 1, 1 plus 64, etc. So change the signs and add. It's going to be a big part of what we do in the next section. Well, but see, you can't subtract from the beginning because our order of operations says you have to do parentheses and exponents first. So that means I have to square this out before I do anything else. I'm going to do multiplication and division. Well, there's no division, but I'm going to do multiplication before I need to do any subtraction. So I have to do this first before I do the addition and or subtraction. So the order we did it in is pretty much dictated. We don't have much wiggle room on that one. So for homework in this section, try 9 through 35 and 45 and 47. Yeah, 5.7, sorry. Thank you.